Hi students, this is lesson 5.2 and we're going to continue solving, and this time we're going to try to undo logarithms. So we're going to solve equations with logarithms inside of them already. Okay. So as a quick little review, you have two properties for logarithms: the power rule, which tells us that we can bring this exponent out to the front and write it as a product. Those are equivalent. We also learned about changing the base of a logarithm. So in this case, we wanted to change it to base a. So we took the log base a of x, that's the numerator, and the log base a of b, that's the denominator, and those are also equivalent. These are the next two properties that we're going to look at: the product rule and the quotient rule. This applies to logarithms of any base that is positive and not equal to 1. If we have the log base a of a product, we are able to write this as that log of that same base of the first part of that product, the first factor, plus the log base a of the second factor. These are equivalent. The quotient rule tells us if we have the log base a, some value a, of a quotient, I can take the log of the same base, base a, of the numerator and subtract the log of the same base of the denominator. We can also do this for the natural logarithm as well. So we can use that same, these same rules with log of any base. So base e, base 10, base 5, whatever you like. These are going to be really helpful when we are solving some of these more complicated equations. So our learning goal today is just like we did with 5.1, except for today, we're going to be solving logarithmic equations. We started with exponential and now we're moving into logarithms. So our criteria for success, we talked about this a bit last class. The first thing you want to know is what was done to the variable. Okay, what was done to the variable. And then we're going to show a clear process. How are we going to undo those steps? Our goal here is to isolate the variable, find the solution. And then very important here to check your solutions, because sometimes even though you did every step correctly, when you go to plug that back in, it's extraneous. It does not work in the original equation. We still follow our algebra rules and our order of operations. And then here's a couple of things we want to keep in mind. So today, especially undoing logarithms, this is called exponentiating both sides. That's how we're going to undo the logarithm. We are going to exponentiate, make sure you know how to say that, exponentiate both sides. And I'll show you what that means in a moment. And then how do we undo an exponential? This is what we did last class. We take the logarithm of both sides. It could be the natural log, it could be log base 10, or any base you like. All right, let's get right into it. So we're going to go ahead and solve some of these together. Make sure you're obviously pausing and copying this down into your notes. And your notes, you're going to go ahead and upload those so that I can have a copy as well. So if we think about our x, and this part you don't have to write down, but if you remember, we did these do and undo steps. So what was done to x first? Well, log base 3 was taken of that x. Okay, so that's the first thing. Then you multiply that by 3. Now to undo, if we're going to undo those steps, we're first going to divide both sides by 3, and then we're going to exponentiate both sides. And then we should be left with x all by itself. So I'm going to first divide both sides by 3. I get log base 3 of x equals 4. How do I undo that logarithm? I exponentiate both sides. So we're going to make 3 the base of the exponential. 3 to the log base 3 of x equals 3 to the 4th. 3 to the log base 3 of something is just the something. The exponentiation has gotten rid of that or undone the logarithm. And so we're left with 81. Now we want to make sure, again, we want to check this and make sure that this works. So 3 log base 3 of 81 is supposed to equal 12. Log base 3 of 81 is 4, and 3 times 4, in fact, does equal 12. So all is good there. So again, if the variable is trapped in a logarithm, you may exponentiate both sides. And the base of that exponential is going to match the base of the logarithm. Okay, go ahead and copy this down. So now we're going to start dealing with natural logs. And please remember, natural log always has that base of e, okay, of whatever, some value, okay? This is the base always, and that's that irrational number. And we're going to be working with that in some context, dealing with some money, okay? But we want to remember that always has a base of e. So let's think again with our do and undo steps. So what was done to x first? Well, it was multiplied by 2, then 1 was added to it, and then the natural log was taken. So to undo, we're going to exponentiate. And what's the base of natural log? It's e. So we're going to exponentiate using that e as the base. Then we'll go ahead and subtract 1. We'll divide by 2, and we'll be left with x all alone. Okay, so let's exponentiate. Again, remember that tiny little base there is e. So we want to raise up both sides. E to the natural log of 2x plus 1 is equal to e squared. Since these two bases are going to match here, we know what we just did is we undid the natural logarithm. So we're left with 2x plus 1 equals e squared. Don't put that in your calculator. It is going to be quite messy. It's irrational. Let's just leave it as exact. We'll subtract 1 from both sides, e squared minus 1, and we'll divide both sides by 2. You could write this. We could split this. This I usually say is my math is love. So we split this way. That 2 is part of that. And then we could say that x is equivalent to e squared over 2 minus a half. They're equivalent, doesn't matter. You can show it either way at this point. Okay, so for the third one, so we have log base 2 of 4x equals 2 minus log base 2 of x. So I'm seeing x on both sides of the equation. I'm also seeing that it's trapped within a logarithm. And I notice they have the same base. Those logarithms have the same base of 2. So I'm actually going to try to collect them on the same side. So over on the left, I'll get log base 2 of 4x plus log base 2 of x, and that is equal to 2. Now we just learned some new properties, and one of those properties says that if I have a sum with the same base of 2 logarithms, what I can do is I can actually write this as their product and write it as a single logarithm. So log base 2 of 4x squared equals 2. Okay, now from here, let's think about what we can do at this point. The variable is still trapped inside this logarithm. So what do we do when that's the case? We exponentiate. What is the base of our exponent? Well, it's the same as the base of the logarithm. 2 raised up to the left side equals 2 raised up to the right side. Since we have the bases matching, we're undoing the logarithm. We're left with 4x squared equal to 4. We divide both sides by 4 to get x squared is 1. We take the square root and x equals plus or minus 1. It's a quadratic. We have 2 possible solutions here. Now we need to go ahead and check our solutions. So if I put in a positive 1, log base 2 of 4 times 1 equals 2 minus log base 2 of 1. Okay, so log base 2 of 4, that's going to give me 2. This is going to actually give me 0, so 2 take away 0 is 2. So that works fine. Now let's try, so this is for trying x equals 1. That works fine. Let's try x equals negative 1. Log base 2 of 4 times negative 1 has to equal 2 minus log base 2 of negative 1. And right away I know there's a problem because I'm not able to take the log of a negative number. So for x equals negative 1, that does not work. That is what we call an extraneous solution. We did everything right algebraically, but when we go back into the original equation, it does not work. Okay, I would like you to try these 2 problems. They are from station 4 and 5, problem 3 and 4. Go ahead and write these down or just do them right in your packet and then pause me and then we can check our answers together. Okay, so the answers for that first one for number 3, and I'm going to actually work them out, but if you match up and you're feeling okay, that's fine. X equals 1/4 to the 5/2 power plus 1. And for the fourth one, it's x equals 8e squared over 3. Okay, and I'll go ahead and actually work those out, but if you're feeling confident and good, you can go ahead and stop your notes here and we will do more practice in class. Okay, so let's take a look at this first one. The first thing I'd want to do here is divide both sides by 2. So we have log base 1/4 of x minus 1 equals 5/2. Now I'm seeing again, I have my variable stuck in this logarithmic function. So this is when we need to do the exponentiating. So I get that same base and I write it as an exponent, 1/4 raised up to the log base 1/4 of x minus 1 is equivalent to 1/4 raised up to the 5/2 power. Okay, so from here, we can go ahead and the left side, since I exponentiated it, is just equal to x minus 1, and that equals 1/4 to the 5/2 power. And then I can go ahead and add 1 to both sides. Now at this point, I can go a little bit further with this 1/4 to the 5/2. I can take the square root of that and then raise it to the 5th power. I think at this point for the video, we're just going to stop right here, but I will show you in class how we can go a little bit further with that one. For the fourth one, we see another property, and that is the difference of 2 logarithms with the same base. Remember, our base for natural log is e. So what we can do here is we can write this as the natural log of 3x over 8. And that would be equal to 2. From here, if we have the variable stuck inside a logarithm, we need to exponentiate. So we're going to raise e, remember the base is e. So e raised up to the left side, we don't really need to write that, e natural log of 3x over 8 equals e to the right side. We have to do it to both sides. So since these bases are exactly the same, we just undid the logarithm, we can have 3x over 8 equals e squared, which is just a messy number. We can multiply both sides by 8. 3x equals 8e squared, and divide both sides by 3. And that would be your solution. All right, we're going to do a lot more practice. We have lots of problems in those stations. So definitely bring all your questions to class.